What's up, everybody? My name is Wes, and this is Piece Parts. And in this episode, we are making some cool lights for the back end of the Pinto. So, stay tuned. Let's get into it. Okay, so to start off with, if you've seen some of the videos, you may have noticed that the car does not have stock taillights on the back of it, and stock lights are kind of boring and they're kind of simple. A long time ago, my uncle threw in some trailer lights on the back. They're just like 4-inch round trailer lights, is what they are. And growing up, I always saw the back end of the car more than I saw the front end of the car, and I always just liked how that looked. Some of you may not, and that's totally fine, but I think it looks cool, mostly just because that's kind of what I grew up seeing. And the idea for those was always to have them be sequential. There was 3 lights on either side for the total of 6 lights, and something similar to like the Mercury Cougars of the time, and even like some of the newer Mustangs and things like that have 3 sections and go in a sequence. And so that was kind of what my uncle and my grandpa maybe were trying to replicate when they were doing that. And so when I started kind of taking over this project, I was like, well, I could do something way cooler with that and do some fancy RGB stuff and all kinds of stuff, and kind of have some fun with it while still kind of getting all the required functions that I need out of it. So that was my goal for this. And so what I did for that was I took the stock housings, and you can see here they're basically a 4-inch round flange mount trailer light that has a red lens. There's a little metal retaining ring that holds the lens in place, and then inside is just a dual filament 1157 bulb, and that was enough to get you by for the trailer lights. I'm gonna do things a little bit differently, and so my plan was to kind of go off of some OEM cars, and all of the cars that I've looked at when I'm thinking about these kinds of things, that as I'm just either out driving or doing my own kind of research. One thing that I notice a lot is that with LED lights in cars specifically, you rarely ever see the actual LEDs, and they're typically reflected around, maybe even back and forth in some occasions, and you're usually really kind of spreading out that single point of LED into multiple surfaces so that you get more light output out of it. So knowing that, I kind of went with a little bit different approach than some might have gone. It would have been pretty easy to just take some halos and throw them in the back of there, or maybe even just a round panel of lights, and make that be red for your signal or for your brake lights, and then have those 3 just sequence like that for your signals. But I wanted to do things a little bit differently, so I opted to do a flexible strip around the inside of the cylinder, and so basically, then I had the lights aiming inward, and I kind of thought about it some, and I was like, well, I need some kind of reflector to aim the light kind of out at you. And so what I ended up doing with that was I modeled up this small little cone shape that would kind of take the light from the outside ring and kind of fire it out the end or out the back side of the light. And so then I modeled that up in Fusion 360, and then I printed 6 of them out, and then I printed them out in black PETG, and the material will hold up in the temperatures and things like that, but it's obviously not reflective. And so when I was trying to figure out how to basically get a mirrored surface on a 3D printed part, I'm looking to some of the other industries that do this commonly, such as like RC cars, or even like car models, or even on cars themselves. You see lots of plastic trim on vehicles nowadays, but it's chrome. And so they typically use a process called vacuum metallization. It's a very long, in-depth process that is pretty tricky to do in your home garage. And so I tried looking into some of that and trying to figure out if I could chrome plate some 3D printed parts, chrome plating, and I kind of abandoned the idea just because it's going to be kind of tricky to get right, and you have to have certain chemicals and all kinds of things, and it's also expensive. There are, if you're doing mass quantities, it's not that expensive, but there are some products out there that you can spray on kind of like a paint, and you could spray them onto any kind of material, and it chrome plated essentially is what it looks like. Um, and I didn't want to invest in any of that because it's quite expensive for what it is. And so I came up with the idea to use some vinyl wrap that has a mirrored look to it, a mirrored surface to it, and being that it's vinyl wrap, it's got, it's not a perfectly smooth surface, and so it's not going to be a perfect mirror, but it definitely gets the job done in terms of reflecting a lot of that light that's being fired at it. So I opted to go with something like that, and then basically what I did was um, flattened out my cone shape, and then I cut that out on our Cricut machine. So I cut out 6 of those, and then I very, very carefully, and it's kind of challenging. Once I did 1 or 2, I got the hang of it, but then I wrapped that around the cone that I had printed. Um, I made sure to knock down some of the imperfections first. You can see here, this was the old one. Sorry, this was the first print that I did, and it didn't come out very good. I had some settings that were kind of iffy on my printer, and so I ended up printing another one and redoing this one, and it came out a lot better. And so basically, I knocked down some of the other imperfections and stuff on it with just some 600 grit, and then wrapped the chrome vinyl wrap on the 3D printed part, and it gives me a pretty good reflector. I could probably have some standardization for how high or how far down the LEDs are mounting on the inside surface of that, to get my perfect ring every time. But so far, it seems to be like a pretty good solution. I don't think I'm going to be revisiting that in the future. But so I got the reflector done, and then I basically had to make some more of the rings. Essentially, they're flexible strips, and so I basically cut the strip into 44 light segments, using 44 LEDs per light. That's just what happened to work out the best. 45 actually fits around a little bit better, but I opted to leave a little bit of room for some of the wiring, so there will be kind of a small gap, but once the lens is on there, it doesn't, it's hardly noticeable. And so basically what I had to do is I'm using the WS2812 strips, and in the 144 LEDs per meter configuration, which means that the LEDs are very close together, and so I get a lot of LEDs packed into one small space. And so I'm using those with the Blue Ghost module from Ghost Lighting, and that allows me to control all of my basic car functions for tail lights, brake lights, turn signals, and as well as having seemingly limitless show modes. And I can do all those show modes connected to it by the app via Bluetooth. And so that's kind of what I'm doing there. Some of the other formalities of the project here. The LEDs that I'm using are a 5-volt LED, and the Blue Ghost controller can use kind of whatever voltage you need. And so on my other projects, I've used it running in 5 volts. However, the inputs that are going to be coming in from the car, the signal for a 12 volt, or sorry, the signal for a turn signal will be 12 volts. Same with the signal for the brake light, it'll be 12 volts. So basically what I did there is I'm running a converter to knock down from the 12 volt input, or 13 and a half, wherever the car is going to be at, down to the 5 volts, and that powers the controller and the strips, and then the signals will all come in as a 12 volt signal into the controller. In order to get my different colors, I kind of thought about a few different ideas. The stock lenses are red, and I wanted to be able to see the RGB different coloring behind the lenses. And so I thought about maybe casting the stock lens and then pouring them in some transparent resin. And then I had a brain fart moment and realized that Well, they make the same lights, but for a reverse light. And so what I ended up doing was buying the same lenses that fit these housings, but they're for reverse lights. So it's an Optronics A41CBP, and they're like a dollar or two a piece. So I was able to get several of those through O'Reilly. And while I was there, I also picked up some new gaskets for each lens, for each housing, which was the A42GBP. And so I picked up another 6 of those. That way, once I put these in the car, I can seal everything up, and hopefully they will seal from the elements into the car and vice versa. So a couple of the things to note about this project: the strips that I'm using that have the 144 LEDs per meter, that spacing is very close together, and so you don't have very much room to solder any wires onto those pads there. And so what I usually do, and what I've done several times in this situation, is sacrifice one LED basically. I'm using a full meter of this, and so I have technically 144 LEDs to play with, and I'm using 44 lights per ring per housing. So I have a few extra LEDs to play with. So basically, you just cut it too close to the next one, and then that gives you the whole solder pad to solder your wires onto. And so that's how I've gone about it, and it's pretty tricky to solder onto these things, but it's definitely doable. So to prep the housings, what I did was I pulled the lens and I pulled the retaining ring out, and then I pulled the lens out, and then you can kind of see there it's just a bulb kind of just placed in there randomly with some aluminum foil tape on the back side of the housing to kind of aim some of the lighting, but it doesn't aim much. So basically what I did there was I popped out the wiring. It just kind of pushes through the inside of the housing there, inside of the connector, I guess, and then took a step drill and drilled out the actual socket, and then I was able to kind of pry it off, and then have the actual socket removed from the housing. It's pretty simple to do, but I did have one or two that spun, and so I couldn't drill it out very well. In fact, I tried a few things and ended up cutting myself, so be very careful if you're going to try something like this at home. I was obviously not, and I cut myself, so big whoop, these things happen. I'm fine. So, yeah, so then once I did that, I basically pulled off the aluminum tape in there because I'm going to have my reflector inside of there, and so there was kind of no need for it. And then I cleaned up the inside of the housing as best I could, just with a wet rag, wet paper towel. It probably could have scrubbed them with some soap and water, but I didn't think it was really necessary, so just cleaning them up with the paper towel got them good enough. And then I was able to place the LEDs in there and silicone everything in place. And then what I will do is I will affix the reflector housing, or the reflector, into the housing, so that it does not move. And then I can seal up the outside of the lights, throw them on the car, and then they'll be done. To connect the wires to the Blue Ghost module, I'm using some 3-terminal JST connectors. That's kind of the standard that a lot of people use for these strips. These are also not weatherproof connectors, so I try to keep them inside of the vehicle where it's not going to see any of the moisture or anything. Okay, so now that we have them built, let's go throw them on the car and see how they look.
Okay, and so here I can configure it to the car. Here I'm telling you that I want to do the wave with this color, I can set my brake signal to these certain things, different parameters for how it does those functions. And here's where I set up that I've got 3 essentially halos, and telling it how many strips there are, or how many lights there are on each strip. And then once we go here, we can do some fancy show modes, and this is where we get the really cool stuff.
Yeah.
Alright, and with that, that is going to be a wrap on this video. I am so stoked for how these things are turning out. Basically, I just got to finish up the wiring. There's a few more things that I'll have to do to the car to kind of change some of the wiring up a little bit and make it work right, and then it'll be ready to go. Then it'll have tail lights at least. So thank you guys so much for watching, and I'll see you next time. Peace out.